So I just wanted to go over some of the things in my Mpls VPN network here, which just made a recent blog post about. The first thing that I want to go over is the route distinguisher and the route target. So the route distinguisher is just to keep the route unique globally within the BGP VPN v4 table. So for example, if we go on R4, show up BGP VPN v4 all, and we just pick a random subnet here. Let's pick 14. So if we do a show IP BGP VPN v4 VRF, name of the VRF, and then the network. It's a bit slow here, 1 second. The 14 network. Show IP BGP, that's what I'm missing. So we can see the first thing that we can see here is it says this is the actual route in the BGP VPN v4 table, which is what makes it globally unique. If I do a show run section VRF, you can see that for our London branch VRF, which is this route on the left here in this section, we've used a route distinguisher of 64512:1, and we can see that gets added to the front of the route when we look in the BGP VPN v4 table. We can see that it actually appears as the BGP routing table entry for 64512:1, and then the actual subnet. So that's what keeps it globally unique. So every time you change the route distinguisher, so say you use 2 here for another customer, in my example on my blog I use Microsoft, so we change this to 2, and this would then appear as 64512:2, and then the subnet. So that's what keeps the route globally unique within the BGP VPN v4 table. The next thing is the route target. That's what's going to identify what routes you want to receive from different VRFs. So when you create your VRF, you have the option to import and export different values. So let's say I'm on router 6 and I want to just receive the routes from the Google London branch here and not the Manchester branch. I would just simply look at what routes are being exported on router 4 within the Google London VRF, within the Google London branch VRF, see what that export value is, and import it. That's the only thing I would need to do. I wouldn't need to do anything more than that. So if we look at if we go to our VRF section here, show run VRF, we can see that if we go over to router 4 quickly and just look at the export value, so the export value is for the 14.14.14.0:24 is the value we decided we're going to export for our London VRF branch. So on our 6, that means that we would need to import this particular value. So if I just paste that underneath, we can see that we do a route target import, and I've included it here. So that's the actual subnet I've just pasted from router 4. So we need to import that on here. We could get rid of the middle route here, and all that would do is get rid of the subnets that are within the Manchester branch. So I mean, I could go ahead and do that now. If I just go ahead and do that, and you can see from the BGP VPN v4 table here, when I do show VPN v4, show IP BGP VPN v4 all, that we have 1, 2, and 3, which are loopbacks on routers 1, 2, and 3. We have the 14 network, the 25 network, and the 36 network. So let's say we want to only import routes from London and not Manchester for this particular customer. We'd go into the VRF. We do all we need to do is remove that line of code there. No route target import there. And the reason this is we're deleting this line is because on R5 that's the value it's exporting. So if we go on to here in router 5 and we look at the show run section VRF, the value I've decided to use to export routes for this particular VRF is the 25.25.25.0:24. So if we got rid of that and looked at the show IP BGP VPN v4 all, we now lose the routes, the 25 route and the 2.2.2 route because we're no longer importing them into our particular VRF. So that's all that does. I'm just going to put the routes back in. Verify reachability there quickly. So if you go on R3, it might take a second for that to populate. I'll check that in a second. I'm pretty sure that will come back in. But yeah, that's the purpose of the route distinguisher and the route target. The next thing we want to check is the MPLS traffic flow. How does that work exactly in the backbone? So just want to check this working again. Okay, cool. It just took a few seconds to update. So the traffic flow, how does that work from router 1 to router 3's loopback, for example? Let's give a quick reachability test. Make sure everything's configured correctly in both ways in terms of redistribution. Ping 3.3.3 source loopback 0. Okay, that means we've sent a packet from the back here all the way to the loopback here, which means it's working properly. So how does the traffic flow work? So when the traffic hits router 4, we're going to then use MPLS across the backbone here to hit R7, then R6, and then bring it out on R3. The way that this works is done with labels. So the first thing we need to do really is see what label we need to use to reach that destination, because we always work on destinations. So the 36.36.36.0 network, if we hop onto R4 and we do a show IP BGP VPN v4 VRF the London branch, and then put the subnet in, which would be 36.36.36.0, we'd see that the next hop is 6.6.6.6, and the label we have to use for it is 606. We've been told that from R6, he's put his own label binding for this particular subnet, advertised it across in BGP, and we can see in multi-protocol BGP rather, and we can see now that we need to use the 606 label as the bottom of stack label for that particular destination. We need to know now what the label is to reach the next hop, as we're only going to be using MPLS in the backbone. So we can see that we need to reach the 6.6.6 network. So if we do a show MPLS forwarding table, you can see that the 666 where it is there, we've been told to use the label of 701 as the outgoing tag. So the top of the stack label, sorry, we start from the bottom. So to reach the 36 network, we need to use the 606 as the bottom of stack label. And then to reach that 36 network, we need to go via 6.6.6.6, which is actually a loopback on R6, which is using to peer via IBGP to R4. So R7 is only using MPLS here around the backbone. So we've put this label on the bottom, we then put label 701 on the top because we've been told to use that label from R7 to reach that particular prefix, and it goes via the fast Ethernet 01, which is the interface connecting to R7, via 47.47.47.7. Fine, so we can reach that just fine. So when the packet gets to R7, it then says, okay, so what do I do? What's going on here? Why does this say R4? Just let me reopen this window a second. Not sure what's happened there. If we go over to R7, and we do a show MPLS forwarding table, we can see that when router 4 sent the packet with the label 701, I believe it was, to reach 6, yep, 701. When we see a local tag of 701 come in, we're going to pop that off, and then forward the packet to the next destination, the destination, which is the 6.6.6 network, via the next hop of 67.67.67.6. But what will happen now is that the top of stack label is then taken off, leaving only the bottom stack label there, which is 606, for R6 to deal with. So we hop on R6 and we show MPLS forwarding table. You can see that when it comes in with a 606 label, it says aggregate, which basically means we're going to route it. We're going to send the packet via IP routing rather than MPLS. So that's basically how the traffic flow works from router 1 to router 3 through the MPLS backbone. The final topic I want to talk about quickly, it's a short topic really, is the BGP peers here between the iBGP neighbors. They must be done via the loopback interface, and the reason is if you don't, it kind of messes up the MPLS. So when we sent the packet via MPLS from R4 across the MPLS backbone to reach the 36 network here, in my example a moment ago, we sent the top of stack label as 701 and the bottom of stack label as 606. What happens if you wanted to use just the 67, 67, 67.6 as your source for your BGP peerings rather than the loopback 0? So you'd say you just put, instead of, if I do a show run section BGP, if I just remove this line, for example, this the neighbor 44444 update source loopback 0 and just left it as neighbor 44444 remote AS1 and left the IGP to route between that and work out the labels for it, what actually happens is R7 then sees that as a directly connected subnet as opposed to it not directly connected. So at the moment R6 is using the source as loopback 0, so it is not directly connected to R7, so therefore it needs to use a label to reach that particular prefix. So if we use 67, 67, 67.6, R7 then says, okay, that network is right. I know where that is. That's a connected subnet. So it sends R4 a message via MPLS to say to use an implicit null label. So what actually happens here is we receive the label binding for the 36 network via iBGP and use the 606 label on the bottom of the stack. We never get a top of stack label to use because we've been told to use an implicit null label from R7. So therefore, when the packet gets to R7, it takes the top of stack label off, which is 606, and then tries to route it to the 36 network, as opposed to sending it via the MPLS. It actually tries to route it. That's the problem with using the neighbor statement without the update source as loopback 0. I think that's all the points I wanted to cover in this blog post. I don't think there's anything more than that. Yeah, so hopefully this helps, and hopefully this helps me remember anyway. Thanks for watching.